Hi everyone, in this video today we are going to be going through the second idea of continuous random variables, and that is we're going to be talking about probability density functions, and in particular something we call uniform probability density functions. So if we just take a quick look at the syllabus here, it says here in the second item, examine the concepts of a probability density function and probabilities associated with continuous random variables given by integrals. So we're not going to do any integrals, we're going to just do the real basics here and look at uniform probability distributions. So what is a probability distribution function? All it is it's a function where, firstly, the function is greater than 0. Because we're aligning this function with probability, you can't go below the axis. So first point there is that the function has to be greater than or equal to 0 for all the values of the domain of this function, so all the kind of x values. Secondly, the area for all the values, the area underneath the curve has to be 1, because we're going to align this with probability. And since we are aligning it with probability, the third thing about it is that the integral has got to be the total area has got to be equal to 1. So they are all the distinguishing characteristics of a probability density function. So let me give you a really simple example to start us off. So imagine you arrive at a ski lift, for example, and the lift goes every 5 minutes. So it's rotating around, and we know that there's a lift that comes every 5 minutes, and you arrive at any just random time, you roll up, and the random variable I'm going to define here is the amount of time you have to wait for the next lift. Okay, so first of all, this is a continuous random variable because time is a continuous random variable. So we could be waiting 3.68257139 minutes, really, or infinitely many time if we're really measuring really accurately. Okay, so that's the first thing. This is a continuous random variable. What would it look like if we were to draw this thing out? So let's do that. First of all, you might arrive at the instant the lift arrives, which is great. So your waiting time could be 0, or you might arrive the instant after the lift has just left, in which case you've got to wait 5 minutes. Okay, so this is time in minutes along here. Now, so what's the distribution look like here? It's a pretty simple one. It looks like that. Okay, because you arrive at any random time, the amount of time that you have to wait for the lift is just looks like this. So again, because this is a probability density function, we know that that area there must be 1. The area under that curve has got to be 1. So therefore, we know that this value on the axis here must be 1/5 or 0.2 in order for that area there to be 1. So now I can say answer questions like this. We've got our probability density function. What's the probability I wait between 2 and 3 minutes for the lift? So 1, 2, 3, 4. So basically that is that area there. You can see 1 times 1/5, 0.2. The probability that we wait between 2 and 3 minutes is 0.2. In fact, the chance of you having to wait any 1 minute interval of time anywhere under there is 0.2. This is called a uniform probability density function. So the line just goes straight across like that. And we can talk about things, what's the average amount of time you wait, which would be right down the middle here. So you could say that the expected value of this random variable here is going to be 2.5. So it's just the value right in the middle of that interval there. So there's an introductory idea on this. So are these PDFs? Let's have a look. For the first one, it's greater than 0, looks good. Is the area equal to 1? So the area of this thing here is a half base times the height is 2, which is 2. No good. So that first one there is not a PDF because the area under the curve is 2. What about the second one? It looks all positive. The area here is a half base times height. The area is 1, so this one is good. That's a probability density function. that we'll study in the next video. It's not a uniform one, but we can study those in the next video. We can do the same kind of thing and work out probabilities associated with the area underneath the curve. So let's look at this PDF. We've got between 1 and 5, so it's only defined between 1 and 5. You can see that the probability density function is 0 for values less than 1 and greater than 6. You can see this part of the graph here. So it's only working for values between 1 and 5. So what's the value of k first? We know that this area here must be 1. So 4 times what will give us 1, so k must be equal to 1/4 or 0.25. Okay, I'll just leave it as a decimal, 0.25. What's the probability that x is equal to, x is less than 3? Okay, so what's the chance x is less than 3? That is just the area underneath this thing from 3 to 1. So when it says less than 3, we're only going for the values that this PDF is defined for you. So it makes no sense to go 3, 2, 1, 0, -1, -2, because values less than 1 just aren't included in this function. So when it says less than 3, what it really means is between 3 and 1. Okay, so the area under the curve gives us the probability. So we've got 2, the base 2 times 1/4, so that is 1/2 or 0.5. What's the chance that x is between 2 and 5? Again, it's just the area underneath this thing between 2 and 5. So it's that thing there. So again, the area is 1, 2, 3 times 1/4, 3/4 or 0.75. And the conditional probability one, what's the chance that x is less than 3 given that it's between 2 and 5? Okay, so given that we know it's between 2 and 5, so we know the bottom line is 0.75. Remember, the top line here has got to be what's common to being less than 3 and between 2 and 5. Okay, so let's draw this out. So what's common to being less than 3 and to be between 2 and 5? What's the common ground of those two? And you can see the common ground there is being between 2 and 3. So this probability here being between 2 and 3 is 1/4 or 0.25. So we've got 25 over 75, or you could just, this is 1/4 divided by 3/4. It's always good to know your fractions. So that is just 1/3.